Hi, folks. Phil Goddard here. I'm a member of the Telco Cloud Solutions team over here at Juniper, and today I'm here to speak to you about why the first wave of function-first telco clouds failed. Over the next 20 minutes or so, I'm going to speak to you about two broad approaches that were undertaken in this journey and how we at Juniper have evolved one of those approaches into what we described as cloud first. So it's been about 8 years since ETSI published its NFV white paper, and as you can see in the chart, operators have been busy adopting and deploying lots of virtual technologies. While the ramp is picking up, the results have actually been kind of mixed. STL Partners surveyed over 20 top telecom operators, and the majority of those interviewed felt that while the technology works, it's not really delivering the expected cloud value of being open, vendor neutral, and even agile. STL concluded that the root of the problem wasn't in the telco cloud vision per se or technology itself, but rather more in the way the clouds were deployed and operationalized. With service-led, the development of the cloud was driven by the need to virtualize a specific function. In many cases, this began as like a core, a mobile core, and also included maybe an IMS system. With platform-led, the development of the cloud was more of a top-down effort designed to incorporate a broader set of requirements meant to support a set of known or anticipated network function workloads. So it would start with an EPC, include an IMS, and probably several other pieces of infrastructure. In the coming slides, I'll dig into the details of these terms and how they affected the cloud results we have today. So while we all understand that telco cloud is about digital transformation, let's go back to the beginning for a minute to remind ourselves how this all started. What were some of the factors that made cloud technologies interesting to our operators? On the left of the slide, we've characterized how our legacy solutions were broadly put together. Many were purpose-built on custom hardware with specialized software to solve a very specific need, like being a GGSN or G or a PE. These were long-term purchases and afforded vendors the latitude to kind of do their own thing. I think we all understand how this contributed to the perception of vendor lock and the creation of specialized operations teams. As the industry virtualized, VNF vendors followed the path of least resistance, and in fairness, the path of least risk to them. They unpacked their applications from their purpose-built chassis and line card architectures, and they reconstituted those architectures to a fault into a cloud environment. In an effort to deal with the inevitable performance hits of general purpose compute, they optimized the entire environment around their specific VNF. Net, we got custom server configs, custom fabric configs, SRIOV. Effectively, we created a vertical stack, or as we've defined, a function-first solution. So while on the one hand, they delivered a virtualized solution using cloud data center building blocks, and that was all good. But on the other hand, you kind of got to say they sort of failed. They replaced a high-performance hardware appliance with a new general-purpose appliance built with lots of general-purpose compute to offset the performance delta. This was the new scale-out. Seriously, this was a great time to be selling servers. But most surprising thing of all, though, was that they successfully avoided, and I mean completely, delivering any of the fungibility or agility that was the real promise of cloud-enabled solutions. It comes back to the fact that VNF vendors really focused on the virtualization of their physical appliance and not the development of a cloud computing platform that would have required a more significant investment on their part in expertise and process reengineering to actually realize any of the targeted benefits of cloud outcomes. Now, when we think about using cloud to transform your business, it's intuitive to think about it in terms of the people, the process, and the technology. But in doing so, there's generally been a tendency to disregard or maybe diminish the sometimes intractable issues associated with each. I mean, with the people, there's still a serious lack of software DNA and skills. Teams are still learning to build and operate as they go, and the new realities these infrastructures present are adding to the disruption as service providers constantly reorganize in an effort to try and stay aligned. With the process, look, they stuck with what they knew and they attempted to stretch what they had to fit the new model. And as far as technology goes, well, I mean, virtualization was really only the start, kind of the equivalent of letting the genie out of the bottle. There was still orchestration, disaggregation, containerization. Hell, there's probably a few more izations we haven't even thought about yet. And then there's the whole issue of lifecycle management. And I mean the lifecycle management of everything. There's the servers, the fabrics, the OSs, the hypervisors, it goes on. And the pace of all this change, well, accelerating. Telco cloud is an investment in the business. to develop and introduce new services at a pace and a cost model much more in tune with that of a hyperscaler. It's about time to market, time to revenue, and it's about the ability to pivot at a moment's notice. For those service providers embarked on a 5G journey, there's simply no other alternative. But it's a tough pivot. I mean, the hyperscalers weren't burdened with the baggage of history that today's service providers carry. So service providers, if they're determined to build their future growth on a hyperscaler model, they're really going to have to transform their infrastructure, their business processes, and their people from a model of multi-year time horizons and a very few large bets to inserting code changes into live networks on very short turns without maintenance windows. You know, just to drive the point home, let's take a step further with a simple example. Let's take an existing MOP that defines the steps to accurately and consistently perform what is otherwise a very routine task of replacing a line card. It's a pretty basic example, but for anyone with an operations background, you're going to understand the importance of these kinds of procedures. Now let's do the whole thing all over again, but this time let's make it more interesting. Let's make the line card virtual while trying to use the same old operational model. As you can see, we experience multiple issues, which was once considered using the gold standard of process and procedure. Now, as ridiculous as this example might seem, I've actually witnessed comparable behavior up close. I've watched techs label servers with the names of hosted workloads in an effort to easily find them again should they require troubleshooting. Imagine the horrified look on the tech's face when told that the workloads within their clouds are not anchored. They move. And that movement may even be instigated by the infrastructure itself for any number of reasons. Now, despite the exaggeration of the example, there's two critical points worth mentioning here. Point number one, the old MOP simply won't work. Minimally, every MOP will need to be prefaced with, how do I find the virtual equivalent of X? Or worse, every step will need to be rewritten and revalidated. Second thing is, your operations team will really need to be reskilled to include knowledge around servers, NICs, OSs, hypervisors, on top of their usual day-to-day jobs. I mean, the punchline here is there's really no way around it. Unless the business processes are transformed, and I mean the methods and the people skills, it's not really possible to realize the full potential of Telco Cloud. And that thinking and investment has to be institutionalized right from the very start. Okay, I've been talking about Telco Cloud for a few minutes, but it's worth taking a second to do a quick review of what constitutes a Telco Cloud. I'm sure all of us have seen the obligatory ETSI NFVI software model, but there's really more to it. So at the bottom, we have the platform layer, or the forwarding plane of the cloud. A telco cloud has very unique forwarding requirements and service level agreements that need to be met so that a modern telco cloud will use a mix of processor types from custom ASIC to general purpose ASIC, both in the server and the NIC to match the performance of the service or application requirements. Going up, we have the fabric layer, the home of all the switches and routers that provide the physical connectivity between all local compute and storage resources and the wide area beyond. High performance, low latency, and seamless interconnect with the WAN are the headline functionalities here. On the third floor, we find the orchestration and virtualization layer. This is the place that includes the VIM, the SDN, the OS, the hypervisors. This is where you do all the arranging and management of the workload objects and the networks connect them. This is the layer where all the magic happens. Now, on the top floor, we have the services layer where we define code and deploy and monetize applications and services, from a brand new packet core all the way out to some kind of a gaming service. Yet we're still not complete. While each of these layers is often managed by very skilled teams, the interfaces between the layers frequently exhibit varying degrees of dependency that cause misalignment of process handoff, making this transition to cloud a difficult journey. Now, to aid in the overall align and bind of these layers, we need network services and functions like telemetry and analytics and automation and all the rest of the stuff I've illustrated on the right-hand side that cut across all these layers. Ideally, we want to define once and deploy many across the cloud platform. So while the upper layers have garnered much of the attention until now, to get it right, due consideration must be paid to all layers and the glue in between that binds them. For this reason, Juniper uses the term cloud first to emphasize this importance. So let's talk about cloud first. What must the platform enable to make it a strategic asset for the operator's transform journey? We start with the edge and service agility. Here we're talking about the ability to deliver any service from any site in the network, any time of the day, month, or year. To deliver any service, the platform has to be horizontally aligned and built to open standards and APIs to make it easy to spin up and quickly deliver services ubiquitously across your infrastructure. The cloud has to support virtual machines and containers equally well, and it has to have a path to cloud native. And there should be choice available on the consumption model, from the usual build and handoff like we've been doing for years to the more evolved managed service approach. Next, it has to be easy to operate. We need to move away from the process-heavy, waterfall-oriented design and operational models towards a more automated approach using agile process and DevOps. The goal here is to eliminate as much of the repetitive and manual overhead that we can through automation and concentrate our most valuable operational assets, our people, on the highest value tasks. Finally, service assurance. I will tell you, this was an idea that was established at a time when services were anything but virtual. It was all about discrete devices connected to each other, configured in very specific ways and benchmarked. The hardware system created was assured to deliver its service at a specified uptime. Now, in the world of today, where we have lots of virtual this and that, we have the same service expectations, but we likely don't even know where these service objects are from 1 minute to the next, how they might be affecting each other, or even their immediate state. So how do we do in this infrastructure what we used to do in the old? Where do we start? The good news is that the early days of server virtualization enabled us to build a foundational discipline around data collection, analysis, remediation. The bad news is we've now all arrived in a world in which the difference between mating and failing an SLA is measured in seconds. And human intervention in the remediation loop, the old way, is not only not helping, it's more often than not making things worse. In this real-time world, not only do we need real-time telemetry capture and analysis, we also need real-time remediation. Now let's dig into the edge and service agility. 5G opens the door to a whole new set of revenue-generating apps and services that likely depend on the availability of low latency, high capacity, and a highly distributed infrastructure. Regardless of where along the journey you are, it should be painfully clear that the further out we push our cloud edge, so move from the right to the left in the graphic, the greater the number of sites upon which a consistent service experience needs to be delivered. We're talking about thousands of distinct edge cloud clusters, not small groups, think large fleets. And while they generally get smaller in size the further out you go, they still all share a common need for command and control. So then what do we need to consider? Well, first, start with an open, integrated, and horizontal cloud stack that can be extended to every site in the network to support any kind of workload, while providing a consistent service delivery experience across the infrastructure. Juniper offers Contrail Cloud, which integrates all the cloud elements into a shrink-wrapped NFVI. Alternatively, for those with needs or even an appetite for do-it-yourself, we also have Contrail Networking. Either way, pick the platform that matches your expertise and proceed. Second, you need a strategy around the management of fleets of cloud clusters. This includes servers, fabrics, workloads, the whole shebang. Juniper offers telco cloud automation with significant experience in some of the world's largest deployments that will enable you to scale your own deployments cost effectively without overwhelming your operations teams. Third, if you lack the breadth and depth to deploy and manage and operate a distributed edge cloud, consider telco cloud as a service. While you might be tempted to partner with a hyperscaler like Amazon, Google, or Microsoft on the basis of time to market, at what point does the brand of the hyperscaler simply overwhelm your own? I mean, the edge is arguably some of your most valuable real estate. So as you move to leverage this asset, you need to be very careful that your efforts don't inadvertently let the proverbial fox into the henhouse. Consider a more prudent and flexible course of action. Juniper has entered into a partnership with StackPath, a global provider of managed edge cloud services, in which we'll be combining our mutual strengths to deliver a managed edge cloud solution. We'll be talking a lot more about the details of the partnership in the coming months, but as part of the virtual summit, Jason Poirier will go into more detail about our managed edge cloud solution and how to use CDN and other cloud platform services to monetize your edge during his session and titled, Get Your Edge Back, Monetizing Without Losing Control. Now, shifting gears to operations, when we look at today's operating environments, They're driven mostly by siloed and independent operating teams, each responsible for different parts of the telco cloud. While these teams operate autonomously, they are generally aligned by a common set of goals and objectives. As an example, we might want to develop a network service that is strict latency and high bandwidth requirement. Today, to do so, we would imperatively tell each team how to implement their portion of the service. When everyone has done their piece and given a thumbs up, we start a service validation testing cycle. But if we have a test failure, we stop, we triage, we root cause, we fix, we test and commit new code and try again. We continue to rinse and repeat until the service is qualified for production, and sometimes this can take months, sometimes even longer if new features are required. With cloud infrastructures, we shift our approach, moving away from the usual imperative style to a new declarative style. With a declarative model, instead of telling the infrastructure how you want it set up, we instead tell the infrastructure what we need and let it determine how it will deliver. In this case, the what is a resilient high bandwidth network slice. With the right automation tooling like CI/CD pipelines, you have the ability to make a declarative intent, convert it to code, compile it, and execute it through a pipeline to effect a change in the infrastructure. This change is based on the optimal set of resources available in the moment that meets the requested criteria. Artificial intelligence and machine learning may further enhance the overall experience in a number of very distinctive ways. You can use it to baseline the normal environment and maintain it. You can use it to refine the declared needs of the application over time. You may use it to identify sources of bad behavior that could affect or degrade the SLA and kick off an action to auto-remediate. Intent-based operations is really about describing the operational characteristics to optimize app performance and then letting the infrastructure do its thing in response. By using tools like pipelines and advanced telemetry with an intent-based operational model, you automate repetitive tasks to reduce manual error. You improve code quality while allowing you to get code changes and new services into production more quickly. Now, we mentioned network slicing in our last example because it's really a compelling technology to use cases across every industry. With slicing, you have the ability to offer diverse services, each with their own performance, latency, and resilience requirements, and the freedom to monetize each any way you want. For example, our blue slice here could be for a low latency IoT app, while the gray slice may offer a low latency, high bandwidth service for remote surgery, or even gaming. What's important to note is that the quality of the service isn't determined by the slice of spectrum carved out at the last mile. The slice's SLA relies on a consistent set of resources delivered across potentially the entire network. Now, when we use a declarative approach, we can define what we need from the infrastructure and allow the infrastructure to use the tools available to it, like SDN control across the WAN and cloud, to ensure that the wide area flows are properly matched to the cloud-based flows to deliver an end-to-end network slice that has the right capacity and resiliency to meet your SLA without you specifically requiring to know how the infrastructure actually goes about doing it. In a comparable way, we can define QoS and security characteristics and be confident that as workloads move, the associated QoS and security characteristics are going to move with them. And finally, with telemetry and analytics, the infrastructure itself will determine when it's running hot and automatically recalibrate without human intervention. So folks, in summary, telco cloud is hard. There really aren't any shortcuts. Virtualization without corresponding business transformation is simply a sizable sunk cost with little payback. The initial wave enabled us to get familiar with the overall challenge and build the necessary muscle. The coming wave, boosted by 5G and the new frontier at the edge, will be no less daunting. And while the efforts of the first wave will remain critically important, the focus of effort will shift in the direction of managing the many and varied telco clouds at scale and at a pace more in line with the hyperscaler. Juniper's telco cloud solution is really a combination of many aspects of our software and hardware portfolio, coupled with maintainable automation at all layers to ensure a cohesive, reliable pool of both hard and soft resources in which to place and execute your infrastructure services in a fully distributed manner, reliably and at scale. Now, while I won't use this opportunity to delve into the product detail, I'm sure there's some links to some white papers and resources that we'll be providing, James. And if you have any follow-up questions, or you just want to discuss other, how other operators with whom we've worked have approached the Telco Cloud solution, we'd be happy to discuss with you further. So in closing, thank you. Please enjoy the rest of your virtual summit with Juniper Networks.